In this lesson, we're going to look at slant asymptotes. Another name for a slant asymptote is an oblique asymptote. So when we think about horizontal asymptotes in the end behavior of rational functions, we have three different things that can occur. We can have a horizontal asymptote where y is equal to 0. We can have a horizontal asymptote where the equation is y is equal to a over b, and a over b are the leading coefficients of the numerator and denominator. Or it does not have a horizontal asymptote. And so for it to not have a horizontal asymptote, it's going to look something like this function that we see here. And so what we're looking for visually on the graph is that these two ends of that polynomial function are going in opposite directions of each other on either side of the graph. And that is our oblique asymptote. We can find the equation of the line that forms that oblique asymptote, and we can do that using division. So we have two different things or strategies that we've learned in this class to divide polynomials. We have long division of polynomials, and we have synthetic division of polynomials. This graph or function can be divided using synthetic division because we have a linear factor, a coefficient of 1 in front of the x. So if you remember, we take and we put the opposite sign in the box in the front, and then the coefficients of the polynomial in the numerator will go across the top row. We bring down the number in the first column, and then we're going to multiply and add all the way across until we get to the end. And then remember that the box at the end is the remainder, because this function does not divide evenly into the polynomial in the numerator, so we have a remainder there. So if we were going to graph this line, it would, kind of follow the sides of that rational function, because it's graphing the line y is equal to x plus 1 that we see on that graph. For this class, we're going to, if I ask you to find a slant or oblique asymptote, it's going to be one where we only have, where it's going to be linear, which means that we would have a difference of 1 between the two functions. We can actually find them for any relationship with polynomials. Again, it would have to be where the degree of the numerator is larger than the degree of the denominator in order for us to find a slant or oblique asymptote.